So now we've got an interesting problem. We want to describe, in interval notation, all points x such that this inequality holds. Now, I think this is actually quite a difficult problem because it's going to require us to break the problem up into different bits, basically. So let's just remind ourselves a little bit. Let's just remind ourselves about how inequalities work. We've just seen this, but if I have, for example, a less than b, and they're positive, for example, that would guarantee that when I take the reciprocals, the inequality is reversed, like that. Okay, so we've just seen this. I wrote it slightly differently with a 1 over b is less than 1 over a, but it kind of reverses the direction if I keep the a still on the left and the b on the right. So that's great. But remember, if, on the other hand, I have a less than 0, less than b, well, then the reciprocal is still negative. So the equality is the other way around. So this is particularly confusing because x, there's no restrictions on x at all, right? I've got to carefully think about how I would get 1 over x, strictly less than 2, into a nice form where I can read an interval off it. So I think I've got to break it into two different camps. One where 1 over x is positive and one where it's negative. So let's just see what happens. I don't know ahead of time what's going to happen here, but the first one is, let's do maybe the simpler of the two, I don't know. So 1 over x, let's have this as negative. And let's have 1 over x. See, my basic plan is the following, just to see what I'm thinking here. I want to get x on its own, so my basic plan is to just invoke the fact that if I take the reciprocal of 1 over x, assuming x is not equal to 0, this is going to be equal to x. So what I'm going to do is, I'm going to think about that as a, that as b, and I'm going to take the reciprocal, which will give me x on one side. So that's my plan here. But I've got to be careful, like I said. If I'm going to flip anything, I need to know if it's positive or negative. So this is actually really simple, right? Because 1 over x is negative if and only if x is negative, and this is true same if and only if x is positive. This is quite a difficult example, right? You're going to have to really think carefully about why I'm splitting into two cases. Okay, so let's do the negative situation. So if it's negative, what do I know? I know that the inequality is preserved. So 1 over x, so let me write this incredibly carefully. So if I flip everything, it preserves the inequality. Okay. But what's this statement? This is exactly the statement that x is less than a half. All right. So that's what happens if negative. What about this statement over here? Well, now, if I flip the inequality, what happens? It's reversed. I maybe should say, some of you might be looking at this and thinking, I can see other ways to do this. For example, you could try to cross multiply by x and divide through by 2. You'd still have the same problem though, because you'd need to think about whether or not x was positive or negative, so you still have to break into two pieces. I'm just doing this to illustrate how I'm really using these. Okay, so we got this, and the inequality is reversed, as I said. Okay, so now this is if and only if, of course, x is strictly bigger than a half. Whew. So let's think about this a moment. I've got it's very confusing, right? These two things that are different than each other. Remember, I only need one of these to happen. Right? I need to be one of these two sides. And this side is kind of probably the most confusing, I think. This side is the most confusing because really what happens here is, okay, if x is less than 0, then in order for this to work, we need x to be less than a half. What does that mean? Well, being less than 0 guarantees you're less than a half. So overall, the condition here The overall condition is that x has to be less than 0. Because if it's less than 0, this is guaranteed to happen. Okay, now what about the other side? Well, the other side, let's get this straight. In order to be on the other side, you've got to be bigger than 0. But in order for this to work, we're going to need it to be bigger than a half. So being bigger than 0 isn't enough to be bigger than a half. Bigger than a half is, it overcomes it, right? If you're bigger than a half, you're bigger than 0. So overall, this is just a statement that x is bigger than a half. Why? Because if x is bigger than a half, that's definitely satisfied. So what do we have? Well, one of these two things has to happen. So at the end of the day, one of these two things has to happen. So putting everything together, what do I get? The interval is, well, on the negative side, just x is any negative number. Union on the positive side, well, you've got to be bigger than a half, don't you? So let me just move this correctly. So this is a tricky example. This is exactly the kind of thing that can trip you up. You've got to think really methodically, precisely because you're going to have different algebra depending on whether or not x here is positive or negative. So let's just a little sanity check. If x is negative, this is negative, so of course this holds. That's down here, right? This is us just going through this super carefully. However, if x is positive, you've got to be sufficiently big to be less than 2, or x has to be sufficiently big to be less than 2 because you're taking a reciprocal. How big? It's got to get bigger than a half. At a half, 1 over a half is 2, that's where they kind of match. Any bigger than that, and this becomes smaller, so you're good. So basically there's this kind of middle ground between 0 and a half where it doesn't work. But again, you've got to be so careful with this. You've got to carefully understand that the negative side has to be treated separately. So I think this is a pretty hard example, but it's a really good one.